Hello everyone, I'm Natan, and today I'm going to talk about SRE agents and how to build affordable SRE agents that you can actually run on all your production alerts. So it seems like everyone's building SRE agents nowadays, and the math of them is actually fairly challenging to make this work at scale. So I'm going to walk through some of that and why they cost so much and what you can do to fix that. As background, I'm the CEO and co-founder of Robusta, so we've been building SRE agents and shipping them to customers from the Fortune 500 all the way to tiny startups, and we've been doing that now for quite some time. So I'm going to share some of the lessons that we've learned on that. Okay, so the naive cost, if we take a typical Fortune 500, you're going to have at least 1,000 alerts per day across different teams. And if you want to run an AI SRE on all of those alerts, the total cost on that with a naive solution is just too high. I'll walk through all the numbers and how I get to this giant figure here for $730,000 a year. But it's fairly realistic, and it matches what we tend to see in enterprise after enterprise. And the math behind this is you're looking at a cost per investigation of around $2, and you're looking at say 1,000 alerts per day. And if you run the math on that, I mean, you very rapidly reach this massive figure. So I'm going to walk through all those numbers in more detail. And of course, this number for most enterprises is more expensive than the cost of having humans triage alerts manually. So it tends to be a non-starter. So we're going to look at how you can bring that cost down. So just to walk through more of the math. So the typical cost for most vendors doing SRE agent investigations is in the 50 cents to $5 range, depending on how complex the underlying issue is. Most of the vendors are charging a markup on that. So most of the observability vendors, for example, are charging around $25 per investigation. And then you have vendors going all the way down to $15 or $5 per investigation. But if you ignore for a second any vendor markup, then just the underlying cost on this tends to be 50 cents to $5 for surprisingly almost everyone across the industry. Where that's driven by how complex the alert is. So a simple investigation that's pulling relatively little data would be 50 cents. Complex investigation goes up to $5. And very interestingly, these are all driven by the cost on input tokens. So like an SRE agent is pulling a ton of logs, a ton of metrics, a ton of observability data. You pay a lot on the input token. You tend to not pay at all on the output tokens. Or, I mean, you pay something, but it tends to be very minimal in what you pay on output tokens. Now, if we look at this, then just taking these two ranges, you get this range of 180K to 1.8 million, depending on the cost per investigation. And taking a midpoint there of around $2, then you get to that 730K. And these numbers are for most companies non-starters at that midpoint. It's just not, it doesn't really pay to do at that range, even though you're getting like faster MTTR. It's cheaper to hire an offshore team and to have them triage the alerts. So we want to play with this math and we want to make that more attractive. One thing you can do, it doesn't help as much as people think, but one thing you can do is to use cheaper models. So all this assumes Opus 4.7. And Opus 4.7 is fantastic, or 4.6, right? Really fantastic model. If you look at the Chinese models and you look at models like DeepSeek V4, then that's actually nearly 3 times cheaper. They're not as good. We see accuracy does go down on the really complex things, but they're fairly decent. The math on this is still not good enough to really get you where you need to be. And like in what we do, what we run with customers, we actually don't use the Chinese models. We use almost exclusively Opus family models because they give that extra result, because we can get the cost down in other ways. But if you do look at this as like a first early optimization, just take a cheaper model, right? One other interesting non-intuitive part on this is actually sometimes the cheaper models, even though the cost per token is going down, we see repeatedly in benchmarks that the overall price doesn't go down by as much because the models tend to have to pull more data. They're like trying to pull logs, but they'll pull the wrong logs first. So they have to try again. So they end up actually using more tokens, even though the cost per token is cheaper. Okay, other optimization. So we spoke about like switching to cheaper model. And then one other really common optimization is doing context and runbooks. So if you look at like a SRE agent, an SRE agent is investigating an alert, and in a simple architecture with no memory and like no learning across investigations, then you need to rediscover in every alert a lot of information about the customer environment and their observability data, and you have to rediscover like how do you actually query their tools, what data lives in different observability vendors. If you have multiple time series database, one for the infra, one for the applications, what lives where. So you end up having to rediscover that context in each investigation. So if you either give the agent context on its own, or you have it auto learn that context and generate memories or auto build skills, then you can actually get the cost on that down by quite a bit, typically is in like the 20 to 30% range. And you can get that down because the agent doesn't have to relearn everything in each investigation. So that's another good optimization. But the big area where we see the biggest optimization is that most alerts are actually duplicates. So if you look at like 500 alerts that are coming in when there's a big production outage, right? Most of those are actually really duplicates of the same root cause. So if you're running investigations naively on each individual alert, then you're just paying a linear cost on that. But if you're able to do grouping, then you're actually able to reduce that down dramatically. Now, there's a lot of different ways that you can do grouping. And the tricky part is to do grouping with LLM. So do grouping that's LLM native, as opposed to doing, like, you don't want to do grouping with old school deterministic rules, because if you do that, then you're losing the whole benefit of the SRE agent, right? And then you end up grouping either too aggressively, where you're grouping together different things that appear the same, but they're actually different, have different root causes, or you're not grouping aggressively enough because you have different alerts that are coming in with different names and from different observability systems, and you want to group them, but they don't match the deterministic rules. So what we do, for example, is LLM native grouping. So we essentially let the LLM generate the grouping rules and then persist those for a certain period of time. And then we do a bunch of other optimizations on top of that. But the core idea is to let the LLM actually control the grouping mechanism, and then to let the LLM control the policy on what triggers reinvestigations and what does not. There are other optimizations also that tie into this. So for example, if you're doing it in this way, then you really have one context window per root cause. And then even when new information comes in on a different alert that re-triggers an investigation, you can reuse that previous context window. And if that context window is hot, meaning it still is in Anthropic's cache, Anthropic has 5-minute cache hierarchy. So if the context window is still hot, then that actually is way cheaper than doing a clean context window. So there are lots and lots of associated optimizations that you can do around this. When you start to apply these, then you can actually get the numbers down to a very reasonable range. And the outcome of this is that you can run AI SRE investigations on every single alert. So when you're at like $5 per investigation, now you have to start being really selective and choose where you investigate and where you don't. When you can get the per investigation cost down, then it's a no-brainer. You just run it on everything. And then the agent can then go and like automatically escalate to a human when there's something that's really important, but initially looks like a low priority alert. So there are all these benefits if you can actually get this in the range where you can run it on every single alert, because now you can drive outcomes like having the AI do all sorts of predictive stuff before problems become P1s. Okay, so just to wrap up, AI SREs are extremely accurate. We see that again and again, but they can be extremely expensive, even more expensive than having humans triage. So to make this economic and to run this at scale, you really have to start to apply those optimizations. And if you're interested, please reach out to me. My email is here, and I'd love to talk to you about how we do this and how you can apply this to your environment.